Hi everybody and welcome. Today we're going to be talking about inscribed angles at a circle. So very similar to what we did last time, except the only difference is instead of the vertex of the angle being in the middle of the circle or the center of the circle, this time the vertex is actually going to be on the circle itself. So I know that sounds kind of confusing in words, but basically we're making an angle. And instead of going to the middle like we did before, we're not doing that today. Or instead going all the way to the end of the circle. So this is something a little bit new. We haven't quite seen this before. So in green, that is called our inscribed angle because all of its points are on the circle. There is a second vocab word that we're going to be doing today, and that's dealing with our arc. So our arc is in blue, and we call this now our intercepted arc. And this is the arc of an inscribed angle. And there's a property for today. So the property is if this is 70 degrees, our arc is exactly half of that. So the idea is no matter what is on the outside, I said that the wrong way, sorry. The angle is half of the arc. So in this case, this would be 140. So pause, rewind. The idea here is that whatever's on the inside is half of what's on the outside. So our angle is half of our arc. So in this case, we're going to be able to say that our angle, our inscribed angle, I should say, is exactly 1/2 of our intercepted arc. So on a practice problem, you might see something where they give you an angle, something like this, and they'll tell you, this angle right here is 130 degrees. And they're going to want to know, what is the intercepted arc? What is x? Well, we know that x is twice what the angle is. So in this case, it would be 260 degrees, or exactly double the angle. And same thing for the other way around. If instead they gave you the arc, you divide that by 2 to find the angle, because the angle is exactly half of the arc. There is a property here that we should write down in our notes. And that property is if the endpoints of the arc are on a diameter, then that means no matter what, our inscribed angle is going to have to equal 90 degrees. So this arc, if it's on a diameter, or it equals 180 degrees, we can say with certainty that whatever we make, no matter where we make it, it is always going to give us a 90-degree angle. And that's a pretty cool way to draw a 90-degree angle. Basically, as long as you have a perfect circle and you have your points on the diameter, you can't mess it up. It's going to exactly be a 90-degree angle every single time. And it looks pretty cool. You can try it on a bunch of different points. So our theorem here is that if our angle equals 90 degrees, then the arc is a semicircle. Or just a really fancy way of saying 180 degrees. All right, so some practice questions, just a lot of converting between, halves and times twos. So again, just to make sure you have those straight. So the arc is the times 2, and then the angle and